Assalamualaikum warahmatullahi wabarakatuh. My name is DAYANG binti Abang Murtaza and I am a final year student under the supervision of Dr. Najmah and also Madam Fazni. The title of my project is Synthesis of Methoxyphenyl Ester Precursor towards Flavonoid Derivatives. Here are my table contents of my presentation. Now let's start with the introduction. As you can see here, this is the structure of flavonoids. Flavonoids are widely used in various fields such as medical and cosmetics. Here are some of the examples of flavonoids derivative, which is isoflavone, flavone, flavanol, and also anthocyanin. The problem statements are that flavonoids are not easily obtained from natural products. Moreover, the synthesis of flavonoid and their derivatives by already existing approaches produce low percentage yield and time consuming. Adding to that, the flavone derivatives are also insoluble in water that makes it hard to use in food or medical industries. Now, the significance of study. The consumption of flavonoid able to prevent high-risk disease such as cardiovascular disease and also osteoarthritis. The development of new flavonoid derivatives given more alternative to the pharmaceutical industry. Develop new pathway for synthesis of flavonoid derivatives at low maintenance yet still less time consuming. The objective of the study is to synthesize of flavone derivative from phenyl methoxyester precursor and also isolate and purify phenyl methoxyester using chromatographic techniques to confirm and identify every compound obtained from the synthesis using spectroscopic technique. The first reaction is the tandem demethylation and ring opening, where it uses TBDMS protected acetophenone and N-dimethylformamide dimethyl acetate in the presence of benzoquinone in acetic acid to produce isoflavone quinone. The next reaction is one-pot multi-component reaction. The scheme above shows that isoflavone 18 can be formed by using one-pot multi-component reaction. The one-pot multi-component synthesis can be used where 3 or more compounds that acts as the starting material. Next is the oxidative rearrangement of chalcones. The scheme shows that instead of using flavonoid as the starting material, it uses chalcone as its precursor. Isoflavonoid undergoes biosynthesis with the presence of 1,2-array migration with chalcone as its precursor. According to the journal by Farkas, the result shows that by using thallium nitrate, the reaction is faster. The last reaction is the synthesis of isoflavone with the presence of Wills-Meyer reagent. The reaction consists of starting material of as substitute phenyl 23 with phenyl acetic acid 24 in the presence of boron trifluoride BF3. The Wills-Meyer reagent was treated with dimethylformamide DMF with a chlorination agent such as phosphoryl pentachloride. An example of Wills-Meyer reagent is SOCl2 DMF. Next is the methodology of the synthesis of ester 30 and 31. K2CO3 acetone, the starting material for reaction 1, which is 27 and 28, and also the starting materials for reaction 2, which is 27 and 29, were stirred for 1 hour and then refluxed for 7 and 11 hours respectively. Next, both reaction was monitored by TLC, thin layer chromatography, and also ethyl acetate was added after that. Organic layers were then dried by anhydrous magnesium sulfate, and also after that the mixture was then extracted by liquid extraction by using distilled water. The samples are then evaporated to obtain crude solid products. Next, column chromatography was used to isolate the crude solid and was further evaporated for 8 hours. The isolated fractions were examined through various spectroscopic methods. The first reaction is the reaction between 2-hydroxy-5-methoxyacetophenone, which is starting material 27, and benzoyl chloride, which is starting material 28, to produce compound 30. The second reaction is between 2-hydroxy-5-methoxyacetophenone, which is starting material 27, and 4-methoxybenzoyl chloride, which is starting material 39, to produce compound 31. This is the result shown for compound 30. The proton NMR result shows the CH3 is indicated by the peak at 2.51 ppm, with the integration of 3 next to C double bond O. The detection of singlet peak at 3.85 ppm shows the existence of methoxy group that consists of 3 protons. The aromatic compound peaks showed multiple peaks from 7.1 ppm to 8.2 ppm. Therefore, compound 30 was predicted to have 14 protons by the proton NMR. For carbon NMR results, CH3 was discovered at 55.52 ppm next to C double bond O. The carbon methoxy group was detected at peak 55.93 ppm. Carbonyl ketone and carbonyl ester were discovered to be present at 198.36 ppm and 165.61 ppm respectively. Compound 30 consists of aromatic carbons at 157.34 until 114.43 ppm range. Therefore, this shows all the presence of all the peaks in compound 30. For the IR interpretation, a significant absorption band at peak to at for 6.85 per centimeter shows a CH stretching bond, whereas the C double bond C aromatic compound and CH stretching aromatic compound had medium absorption peaks at 1451.41 per centimeter and 2917.95 per centimeter respectively. The presence of C double bond or ester stretch were seen at the 1721.64 peak. Other than that, the presence of C double bond O for ketone and CO for aliphatic ether indicates at the medium peak of 1675.18 and 1181.3 per centimeter respectively. Next is reaction 2, which is also almost the same as reaction 1. However, the differences is that the starting material of 28 in reaction 1 is changed to starting material 29 for reaction 2. The singlet peak at 2.50 ppm indicates the existence of CH3 next to the C double bond O. Two singlet peaks are seen at 3.83 and 3.88 ppm shows the presence of methoxy group. Multiple peaks for aromatic protons are seen at the range of 6.9 to 8.2 ppm. For carbon 13 NMR spectra, the result shows that CH3 peak at 22.81 indicates that compound 33 was not formed. At peak 55.90 ppm and 55.66 ppm was observed to be aliphatic methoxy carbon group. Carbonyl ketone was present at 207.26 ppm and carbonyl ester at 165.24 ppm. Furthermore, all the peaks for 12 aromatic carbon for compound 31 are present at the range of 164.21 ppm until 114.11 ppm. For the IR interpretation, a significant band at peak 2918.80 per centimeter indicates the possibility of a CH alkane stretching bond. At 3077.96 per centimeter shows weak absorption peaks of CH bond. There are two strong peaks, C double bond O peaks at 1732.47 and 1678.62, which shows ester and ketone bond 1160.86 per centimeter shows a high absorption peak of CO, which is aliphatic ether, at 1359.77 per centimeter shows the medium absorption peak of C double bond C aromatic group. In conclusion, 26.47% of compound 30 was produced by the reaction between 2-hydroxy-5-methoxyacetophenone and benzoyl chloride. However, for the second reaction, 2-hydroxy-5-methoxyacetophenone and 4-methoxybenzoyl chloride produce compound 31 with the percentage of 27.06%. The spectroscopic method displayed that compound 30 and 31 were successfully obtained. The synthesis of the expected flavone derivatives 32 and 33 was unsuccessful, as can be seen from the spectrum peaks that shows that the compounds are not fully cyclized. Instead, the ester precursors of 30 and 31 were obtained. The recommendation that can be done: comparative study of both one-pot method and multiple method can be done simultaneously. The amount of time heating under the reflux can be increased to boost the kinetic energy of the mixture. And then lastly, the explore different conditions of solvent by using more stronger base such as KOTBU, DBU or ET3N. That is all from me. Thank you.